Hey guys, it's Miss Fantassel. This is a pretty quick section. So this is for Algebra 2, and we're looking at a little bit of conditional probability, but then it really goes into really more of the like ands and ors of probability. So it's a little bit of a combination of everything. But we're starting with conditional probability, and I touched on this a little bit in my last video. Some symbols for you to know that are really going to help you is this symbol. So I have it right here, that little straight vertical line. It means given. So this is saying the probability of A given B. By conditional, they mean something has already happened. So if a first condition has happened before you're looking for the probability of this next event. There's this, it's like an upside down U symbol. And so that means and. So this is saying that the probability of A given B is going to equal the probability of A and B over the probability of B. More so than looking at the formula, it's all you're really doing is like you're changing your sample space when you have a given condition. So instead of it being out of your whole total, it's going to be out of some kind of total of the initial condition, which should make sense when you think about it. And maybe I'll touch more on it when we look at some two-way frequency tables. I think it's easier to kind of think about when you're looking at a table like that. So for our first example, it says the probability that a bus leaves on schedule is 0.92. So I'm just going to kind of start to write this out. So event A is that the bus leaves on schedule. And so the probability of A is going to equal 0.92. Okay, and that's supposed to say the. So the probability that a bus leaves and arrives on schedule is 0.87. So we're going to make event B bus arrives on schedule. And so the probability that the bus leaves on schedule and arrives on schedule is equal to 0.87. What does the probability that the bus arrives on schedule given what is the probability that the bus arrives on schedule given that it leaves on schedule? So I'm looking for the probability that a bus arrives on schedule, so B, given, so that's that line, that it arrives on, I'm looking for the probability that the bus arrives on schedule given that it leaves on schedule. So given A. And so whatever the given is, that always goes on the bottom of your fraction. So this is the probability of A. And then on the top of your fraction is always both of them, so both happening. So the probability of B and A, and it is commutative, so the probability of A and B and the probability of B and A are the same thing. So the probability of B given A is going to equal 0.87 divided by 0.92. I'm just going to plug that right into my calculator, and I get I'm going to round 3 decimal places, so 946 approximately. Okay, so for this next problem, we're going to be looking at two-way frequency tables. So the two-way frequency table below shows the education level and employment status of 242,714 people. So that's my total down here. A person is randomly selected from this group. Compare the chance of being unemployed if the person is a college tech student graduate. So that if part tells you that that's like your given. So we're looking for the probability of a person being unemployed given that the person is a college tech school graduate. So given college tech school. Okay. And so this is kind of what I was saying earlier. So I hate memorizing formulas because I can't. Luckily, you guys don't have to because you can use your notes for now while we're doing this distance learning. But I've never been one to memorize formulas. I have to understand where they come from. So I'm given that the person graduated from college tech. So that means I'm no longer looking at the total. I'm looking at the total of people that graduated from college or tech school. So that's my new sample space. So 99,246. And so of just those 99,246, so I'm not looking at everybody, I'm just looking at these people, how many were unemployed. So I'm going right over here to unemployed. This is where the and part of the formula comes from, because this spot right here is the intersection of college or tech school and unemployment. So that's where that comes from. But it's really because now we're just looking at only college or tech school graduates. We changed our sample space when we changed our condition. So that's where that formula comes from. So then right here, so 6,167. And then I'm just going to divide those with my calculator. So 6,167 divided by 99,246, and I get approximately 0.062. And then they want us to compare that with the chance that a person is a college tech school graduate if he or she is unemployed. So now our given is that they are unemployed. So the probability of somebody being a college tech graduate given that they were unemployed. And so now my sample space is changing to only the unemployed people. So I'm looking at my unemployed total as my bottom of my fraction, or as my sample space. So that equals 27,074. And then I'm looking for the number of college tech people in that unemployed group. So come down here, unemployed. So I'm still looking at their intersection. So 6,160. And then I'm going to plug that into my calculator. And I get approximately 0.228. And so they want us to compare these. When we're comparing in math, we're using words like greater than, less than, those kind of words. So the probability of someone being a college tech, given that the person is unemployed, is greater than the probability that the person is unemployed, given that they went to college tech. And a big thing to note here is that they're not the same. So you can't swap them out and assume that those probabilities would be the same. And this is a good example here. The probabilities of unions and intersections. So unions is or. So any problem that wants you to find the probability of something or something, that's a union. Think of unions as like joining together. The symbol for union or for or is a U. An intersection, that's your ands, and that's the upside down U. Okay, so it's really important that we're knowing those different symbols. And so we're going to take another look at this two-way frequency table. So here it is. We've already actually talked about this rule, but we're going to talk about it again. So the probability of A or B, which is the union, is going to equal the probability A, and then plus the probability of B. But then you have to subtract out the probability of A and B. If you don't subtract that out, then what you're actually doing is you're adding it twice, and I'll show you why. So if I wanted to find the probability of, let's say, did not graduate high school and employed. Well, what this is saying is that I would take the probability of employed. So I would be looking at let me go back. So if I'm looking at just the sample spaces, so the sample space of employed is this total of 178,590. The sample space of did not graduate high school is this total of 13,866. But if I add these totals together, it's going to give me more than the probability of they either graduated high school or they were employed, because you're adding this number 8,252 twice. You're adding it in this group and you're adding it in this group. And so that's why they have you subtract out the probability of A and B once, so that you're getting rid of that second time that you added it. So that's where that comes from. So what is the probability that a person chosen from this group is a college tech school graduate and unemployed? So probability that they're college tech. Notice this time it doesn't say given or if they're unemployed or that is unemployed. They're just saying and. So it's not the conditional, like the line given, it's just an and line. So it's really important that an and U, or upside down U. It's really important that you're paying attention to the words they're using, because it's really easy to miss something like that. So the probability that they're college tech and unemployed is just looking at their intersection, so where they meet over the total, so 242,714, and I'm just going to look for where college tech and unemployed meet. So right here. And then I'm going to use my calculator and divide. So 6,167 divided by 242,714. And I get approximately 0.025. Then they want me to find the probability that a person chosen from this group is a college tech school graduate or unemployed. And so now I'm looking at either or. So my probability should be a lot higher because I have a lot more to choose from. So college tech or unemployed. And so using this formula, I'm doing the probability of A, so the probability of just college tech would be my total of college tech, so 99,246 over my total sample space, plus my probability of unemployed, so the probability of B. So if I go to unemployed, I'm going to that total. So 27,074 over the same total. And then I'm subtracting A and B happening. So I just found that up here, but it's 6,167 over 242, 714. And so that's going to equal approximately 0.409 for the first one, plus 0.112 for the second one, and then minus 0.025. And again, I'm going to plug this all into my calculator, and I get approximately 0.496. So the probability of someone being graduating college tech or being unemployed is 0.496. Okay, here's some more examples. So there's a 75% chance that Mark will get to level up on his latest video game. So I'm just going to kind of keep track as I go through. Probability, level up, equals 0.75. A 50% chance that he will eat dinner. So the probability of eating dinner, that's sad. I feel like it should be higher than 60% or 50%. Okay. And then a 60% chance that he will eat dinner and level up. So the probability of eat dinner, and I have a habit of making that a N, but it should be more. There we go. Level up is equal to 0.60. What is the chance that he will eat dinner or level up? And so the probability of eat dinner or level up is going to equal the probability of A, so eating dinner, plus the probability of leveling up, so 0.75, and then minus the probability of both. So again, to find the probability of one or the other, you take the probability of one plus the probability of the other, so you add them together, but then you subtract out both. So that's that same formula from before, and then you can just plug that right into your calculator. So 0.5 plus 0.75. Okay, and when you add those together, you get 0.65. So the probability of him eating dinner or leveling up is 0.65 or 65%. Then for example 2, it says there's a 90% chance that Belinda will pass her math test. So probability pass math test 0.90. A 60% chance that she will study all night and pass the test. So study all night and pass math test equals 0.60. And a 45% chance that she will study all night or pass the test. So probability study all night or pass math test. What is the chance she will study all night? So the probability study all night. And so we're still going to use that same formula, but it just might look a little bit different. So I know that the probability of study all night or pass math is going to equal the probability that she passes her math test plus the probability that she studies all night and then minus the probability of both. So I'm going to use that formula to help me. So the probability that she studies all night or passes her math test is 0.45. And that's going to equal the probability of passing her math test, so 0.9. Plus the probability that she studies all night, so we don't know that. I'm just going to put probability of B. And then minus the probability of both, so the probability of A and B, so minus 0.60, 0.45 equals, I'm going to combine these, so 0.9 minus 0.60 is 0.3 plus the probability of B, and I'm solving for this, so I'm going to subtract 0.3 from both sides, and I get 0.15 equals the probability of B. So the probability that she studies all night is 0.15. So there's a 15% chance. Mutually exclusive. So mutually exclusive is when events cannot occur at the same time. So an example of that would be like raining and not raining. It can't rain and not rain at the same time. So for mutually exclusive events, the probability of A and B happening is going to be 0 because they can't happen at the same time. So John is going to buy a car. He has driven 2 cars today, car A and car B, but will purchase only 1 car. The probability that he purchases car A, so the probability of car A is equal to 0.42, and the probability that he purchases car B is equal to 0.28. What is the probability that he purchases car A or car B? Well, he's only purchasing 1 car, so we know that the probability of car A and car B is going to equal 0. So I'm looking for the probability of car A or car B. So the probability of car A or car B is going to equal the probability of A, so 0.42, plus the probability of B, 0.28, and then minus the probability of A and B, or minus both. So we know that both is 0, so we can put minus 0, but minus 0 is really not adding or taking away any value. So for mutually exclusive events, when you're looking for the probability of, I messed up my symbol, I just noticed. So this actually should be A or B. A or B, there we go. So the probability of A or B, when events are mutually exclusive, you can just add the 2 probabilities together. So we get 0.7. All right, and that's it for this video. I'm going to try to post this week's video today or tomorrow so that you have that, and then you'll be right on track for where you should be at this time. So I hope that you guys are doing well, and if you have any questions, just reach out to one of us and let us know. All right, have a good day.